Hello everyone, welcome to my channel. Today we are solving search in rotated sorted array. So we are given the array nums after the possible rotation and also an integer target, and we're going to return the index of the target in the rotated array if it exists. If it doesn't exist, we're going to return -1. So for example, we have this array of integers and we have this target number 0. And the original array was in the ascending order, 0, 1, 2, 4, 5, 6, 7. And if you move each element 5 or 4 times in this case, we have this array that's given. We're going to find the target number 0, and we're going to return the index, in this case 4. So the first thing we're going to do is we're going to find the smallest number to find how many times it was rotated, or find the offset. So to do that, we're going to use a binary search. We're going to have a left pointer starting from 0 and the right pointer starting from the end of the array. We're going to check the middle point. So we're going to check if the middle point, value at the middle point is greater than the value at the right point. So in this case, the middle point is 7 and the right point is 2, so it is. So in that case, the smallest number will be on the right side. So we're going to shrink the binary search. So in that case, we're going to move the left pointer to the midpoint. And otherwise, we're going to move the right pointer to the midpoint. And after that, we can break the binary search when L, or left plus 1, is equal to right. So when the left and the right pointers are next to each other. And after that, we can just return either left or right, whichever one is smaller. So for this example, the midpoint 7 is greater than the right point 2, so we're going to move the left pointer to the midpoint, and the new midpoint will be at 0. And 0 is not greater than 2, so we're going to move the right pointer here. And we can break out of the while loop here, and then check left or right, whichever one is smaller is the smallest number in the array, in this case 0. We're going to return the index of that. Index is 4, and that's how many times it was rotated from the original array. So now we know the value of the offset. It was 4, index 4. We're going to do another binary search with the midpoint and also the offset. So the left point will start from 0 again, and the right pointer will start from the end of the array. We're going to calculate the midpoint. We're going to add offset to the midpoint. So offset was 4. So in this case, the midpoint is at the index 0, 1, 2, 3. So we're going to add 3 plus 4. And in this case, there's no index 7. So what we're going to do is we're going to do modulo length of the array. And this will become, so modulo of the length of the array was 7, so we're going to have 0. So that would be the real midpoint. So if we were looking at the original array, the first midpoint would be here. And at index 0, we have this number, which exactly what we would have in the original array. So then we are going to check if the real midpoint, so we can call this real midpoint. So we are going to check if the value at the real midpoint is the same as the target. So we're trying to find the target. So in that case, we're gonna return the real midpoint, which is the index. And if the real midpoint value there is less than the target, then we have to search, shrink and search on the right side. So we're gonna bring the left point to midpoint plus 1, and otherwise we're going to bring the right point to the midpoint minus 1. We can do the binary search while the left point is less than or equal to the right point. For this example, the value at the real midpoint, number 4, is greater than the target, in this case 0. So we're going to move the right pointer to m minus 1. And the next midpoint will be here. And we're going to do an offset again. So in this case, the index 1 plus offset 4 modulo 7 is 5. So the real midpoint will be at 1, 2, 3, 4, 5 here. And the value there is greater than the target number we're looking for. So again, we're going to move the right pointer to m minus 1 here. And the midpoint will be here, and offset is 4, so the real midpoint will be 0, 1, 2, 3, 4. And we found the target number, so we can just return the index, in this case index 4. Alright, so let's write up the solution. So first we are going to find the smallest number, or the offset. So maybe we can use another method for that. So we can have offset variable. We can have find smallest function. We can pass in the array. So let's write the function here. So we're going to have private int, we're going to return int, or the offset number. Find smallest, and the input is the array. So we're going to have the left pointer starting from 0, and the right pointer starting from the end of the array. And the condition we're going to do left plus, while the left plus 1 is less than the right. So it will break when the left and the right are at right next to each other. And we are going to calculate the midpoint, which is left plus right minus left divided by 2. And the condition was if the value at the midpoint is greater than the value at the right point. So we're going to check if the value array at the midpoint is greater than the array at the right. In that case, we're going to move the left point, the left pointer to the midpoint. And otherwise we're going to move the right pointer to the midpoint. And at the end we're going to return either the left or the right pointer, whichever one is smaller. So we can return, we can check if the left is less than the right, the value on the left is less than the value on the right. In that case we're going to return the left point, otherwise we're going to return the right point. So that is the first step to find the smallest number, or the offset. So we'll have that number in the offset variable. So we're going to do the second binary search here. So we're going to have, again, the left point starting from 0, the right point starting from the end, at the end of the array. And this time we're going to the condition is the left, while the left is less than or equal to right. So while left is less than or equal to right, we're going to do a binary search. We're going to calculate the midpoint again, which is left plus right minus left divided by 2 to avoid the integer overflow. And we're going to calculate the real midpoint, which was the midpoint plus offset. So real m for the real midpoint is the midpoint plus offset. This can be more than the length of the array. So we're gonna do modulo nums.length. we are going to check if the point at the real midpoint is equal to the target, because we're looking for the target. So if the nums at real midpoint is equal to the target, in that case we found the target, so we're just going to return the index, in this case real midpoint. And we're also going to check if the nums at number at the real midpoint is less than the target, which means the target number is on the right side, so we're going to shrink the binary search. So the left is going to be midpoint plus 1, and otherwise the target number is on the left side, so we're going to do right assign midpoint minus 1. And after the while loop, it means that we didn't find any target number, so in that case we're going to return -1. Alright. So let's see if this works. Alright, so this was search in rotated sorted array. Thank you for watching.